Hi guys, so this is the teaching tube and today we're going to learn about the action potential
Of an onion.
What? This is not an onion. This is
Okay,
a neuron.
turn your head left and it's an onion.
Did you stop that right? Did you stop that? Oh my god. What?
Just go.
Okay, so this, an onion, no, a neuron is what, okay gosh, you distracted me a lot. So an action potential is how neurons communicate. Just like I talk to you and you talk to me. Okay, you're probably not talking to the screen, but anyways, neurons communicate messages, signals through action potentials. So we're going to talk a little bit about action potentials. This is just the general structure of a neuron, soma, or the cell body. The axon, usually just one per cell, and one per cell, and dendrites, which are usually very, very many and a lot smaller compared to the axon, as you can tell by that purposeful drawing of the two sizes. Also, axons are very long. Sometimes they travel very many distances, very big distances, while dendrites tend to be short and they branch a lot. So,
Like roots.
anyways, ignore him. So this is the 6-step process.
And she wrote an essay. Great.
To how the action potential gets transmitted from one cell to the other. So now you start at the axon hillock. Say the cell is very excited about something. It's going to depolarize at the axon hillock, and the action potential is then going to be propagated the entire way down. And that's step number 1. At the terminal, this action potential is going to open calcium channels and let calcium flow in. The 3rd step is that calcium will help vesicles fuse with the membrane. By the way, guys, this is called the presynaptic cell. This is called the postsynaptic cell. Why? Because in between these two, there's a very small gap that is called the synaptic cleft. And by very small, I mean on the order of millimeters. Micrometers, yes, micrometers. Anyways, micrometers. And basically, we were on step 3. When the vesicles fuse, the neurotransmitter, which are in the vesicle, are released into the synaptic cleft. And when the neurotransmitters are there, they're in there, they're bumping around, they're having a great party, they might end up binding with the receptor on the postsynaptic cell. And lastly, after some time, the presynaptic cell is like, you know what, guys? Party's over. I'm going to reuptake you or I'm going to destroy you. So that's the basic kind of steps of the action potential. And it's pretty straightforward. And it's amazing that just these few steps and a little bit of other stuff, chemistry and stuff involved, is how our neurons communicate.